Hey guys, it's day 3 of 100 days of DSC challenge, and today we have a medium level question which is daily temperatures. Now this question is just an extension to the question we did yesterday, which was the next greatest element. Right, so this question is just an extension of the next greatest element. So let's read the question first. We are given an integer, we are given an array of integers, temperatures, and it represents the daily temperatures, and all we have to do is return an answer array such that the ith element of the answer array is equal to the number of days you have to wait after the ith day to get a warmer temperature. If there is no future day, keep the answer equal to 0. Basically, for each element in the array, we have to find we have to find the next we have to find how many days we will have to wait to get a warmer day, which is how many days we have to wait to get a higher temperature, right? So in this particular test case, you can see that for 73, the next greater element is 74. Therefore, I have to wait 1 day to get the next, I have to wait 1 day to get a warmer day. So similarly for 74, I have to wait 1 day because 75 is just the next day. For 75, I have to wait 1, 2, 3, 4 days in order to get the next higher temperature, and so on. Okay, so now let's understand how to solve this question. Well, I'll say it again. If you haven't watched the video from yesterday, then please watch it, as it will help you to clear the logic of this solution, right? So now to explain this, I will take the test case provided in the problem. So first let's understand the approach by dry running this. Okay. So now we have 73. Now see, yesterday we pushed the elements themselves into the stack, but this time we are going to push the indexes of the element into the stack. Why? Because let me just write their indexes first: 0, 1, 2, 3, 4, 5, 6, and 7. Right. So you can see that for each element, if you know the next greatest element, then you can just subtract the indexes to find the days you will have to wait. Right. What did I say? So for example, for 73, I know that the next greatest element is 74. Therefore, I can just subtract 1 minus 2, 1 minus 0 to get 1. I have to wait 1 day. Similarly, for 75, I know the next greatest element is 76. So I can just subtract their indexes. 6 minus 2 equals to 4. That means I'll have to wait 4 days. So that is our approach. So what we are going to do is, first we will traverse from the back, and this is 73. So we will directly push the index of 73, which is 7. Right. Now we are getting 76. Now 76 is greater than 73. So the element is greater than the temperatures stack dot top. We cannot say directly stack dot top because stack dot top is 7. What we need is temperatures of 7, right? Okay, did you get it? Because this is the array, right? And its seventh element is 73. So that is why we are comparing it like this in this loop. I'll get to the code later. First, let's understand the approach. So now we compare these two, and if this element is bigger, the element is bigger than the stack stop, then we will pop the stack stop, right? And then we simply push the index of this into this, right? Now we go to 72. 72 is smaller than the top of the stack. I mean the element at the top of the stack, which is 76. So we push it here. Then we go to 69. 69 is smaller too, so we write 4. Then we go to 71. 71 is bigger, so we pop, and then we go to no, we won't pop 5 because at 5 we have 72. So 72 is greater than 71. So we will stop here, we will stop popping here. And now you can notice that I am at 71 and I have stopped popping the elements at this, the top of the stack is currently 5, right? So I can simply find the required index, required distance, which is basically the days I'll have to wait, by subtracting the top of the stack, which is 5, minus the current index, which is 3, right? So this will give me 2. So basically I'll have to wait 2 days. So that is how we have coded this. Now let's understand the code. So I have taken a vector, integer, a vector of the type integer, the name is answer, its size is the same as the given array, and all the elements are initialized by 0 because it is the default condition here. Now we will traverse it from the back, and the current element is the temperature's ith element. And now, as I said, while the stack is not empty and temperature stack top, just understand that the element at stack top index, while it is less than or equal to element, we will keep popping it. So when will this stop? This will stop when we encounter an element at the stack top which is greater than our current element. Okay, so now we have successfully popped out all the elements smaller than the current element at the top of the stack. Now, if the stack is empty, that means that there is no greater element, which means there we will have to wait, right? This condition, we will have to wait unlimited days. So we will just write answer 0. So that is why I have not even mentioned that condition here, because if the stack is empty, then the answer is 0, and already all the elements are 0, so we won't have to push anything in the answer array, right? So that's why we have not mentioned that condition. We are mentioning that if the stack is not empty, in that case we are just returning that answer's ith element is equal to stack top minus 1, right? The same logic I used here. What did I say? If the stack is not empty, in this case the stack was not empty after popping at the top of the stack, so we stopped here. So therefore the answer's ith element, what was the ith element here? The ith element here was 71, right? Or 75? It was 71, right? So for 71, the answers third element would be 5 minus 2. What was 5? Top of the stack. Minus 3. 5 minus 3, sorry, equals to 2. So what is 5 minus 3? What is 5? The top of the stack. What is 3? The I. Okay, so that is why we have written this. And then we simply push the element into the stack. Okay, and then we return the answer. So that is how this works. This is a fairly simple question, but it tests your knowledge and your logic building ability. The code part is just small. You just need to understand the logic first. So if you did not understand this explanation, please watch the video from yesterday, because because I did not fully explain the logic of the stack in this question, because I had already explained it yesterday. So thank you guys for watching. See you on day 4.